einem Nobelpreisträger der Physik. Ich präsentiere Ihnen Dr. John F. Clauser. Er erhielt die Auszeichnung, also den Nobelpreis, im Jahre 2022 zusammen mit 2 anderen für Arbeiten aus den 1970er Jahren. Sie zeigten, dass die sogenannte Quantenverschränkung es Teilchen wie Photonen ermöglicht, über große Entfernungen hinweg zu interagieren, was eine Kommunikation über die Lichtgeschwindigkeit hinaus erfordert. John F. Clauser kritisierte bereits die Nobelpreisverleihung im Jahre zuvor, 2021, in der der Nobelpreis dafür verliehen wurde, für die Entwicklung von Computermodellen zur Vorhersage der globalen Erwärmung, zu Recht kritisiert. Clauser hat ein Klimamodell entwickelt, das die bestehenden Modelle um einen neuen, bedeutenden dominanten Prozess erweiterte, und zwar die der Wolkenrückkopplung. Bestehende Modelle unterschätzen dies bei weitem. Das haben schon einige andere der vorgehenden Referenten angedeutet. Und der verstorbene renommierte Physiker Dr. Edwin James sagte bereits, dass Dr. Clausers Arbeit wird sicherlich als eine der unglaublichsten intellektuellen Leistungen in die Geschichte der Wissenschaft eingehen. Und ich glaube, dem können wir jetzt alle nachträglich zustimmen. Ich begrüße Sie herzlich auf der Bühne. Welcome on stage, Dr. John Clauser.
The important part of the talk is the second part, which is where I introduce what I think is really happening, the cloud thermostat mechanism that is really in control of the climate and not greenhouse gases. But before I get to that, I really need to comment about some of the problems with the current models put forward by the IPCC. Which is, I believe that climate change is a total myth. The IPCC and its collaborators have attempted to identify the dominant process, and I believe they botched it. They have been tasked to use computer models and observational data to determine some very important numbers. And these include the power imbalance of the Earth, mentioned earlier, the feedback stability from natural mechanisms that control the Earth, and an important number that goes into this is the Earth's albedo in 2 parts, the clear sky and the cloudy sky albedo, and the whole Earth together. I assert they have totally botched all of these tasks. I will assert that they have totally misidentified the dominant process and correspondingly have drawn incorrect conclusions and made incorrect recommendations. It leads them to incorrectly calculate the strength of naturally occurring feedback mechanisms that I will calculate at the end of the talk. In turn, it leads to the false conclusion that these feedback mechanisms are quite marginal and that we are close to a tipping point. I don't believe that it's true at all. I assert that the dominant process is the cloud thermostat mechanism. I will mention it. And it provides by far, the dominant feedback stability for the Earth. The positive feedbacks associated with climate change or with greenhouse gases are totally negligible by comparison. And so I can correspondingly assert that there is no climate crisis. The climate is robustly stable against greenhouse gases. Okay, so this is put together in what I would consider a house of cards. And that the IPCC has not proven global warming. Their own, did I skip one? No, I did. Okay. The observational data are fully consistent with no global warming. The computer modeling uses very flawed physics, and their claims of a power imbalance are based on dishonestly fudged data. I'm a little bit sad that I have to say this in the public in front of fellow scientists, to accuse people of dishonestly fudging data, but I will show you exactly and pinpoint exactly where they did it. The lack of a real global warming leads to a total house of cards, and I'll get into that in a minute. Okay, and without global warming, there is no climate crisis. Furthermore, I will show you where NOAA dishonestly claims that we have an observed increase in extreme weather event frequency. That's also clearly bogus. Okay, regarding, let me first mention computer modeling. Computer modeling performed by the IPCC and its collaborators, particularly mostly done by the Goddard Institute for Space Studies, is totally incapable of simulating the past climate over several decades. It can't even get the temperature history correct, but much worse, far more important, it's way off in getting the total reflectivity of the sunlight and the total albedo of the Earth. The computer modeling is even worse, and I believe there is something very, very wrong with the physics that the cloudy sky albedo appears to be wrong by a factor of 2. It's very hard to make errors that big. Okay, regarding the observational data, they're fully consistent with no observational data, fully consistent with no global warming. And so correspondingly, there's no climate. The reports of net global warming are dishonestly fudged. Okay, it is based on several sources: satellite radiometry, ocean heat content, and these two measures are grossly in disagreement with each other. And I'm not the first whistleblower on this. Trenberth and Fasulo earlier pointed this out. And there is no data closure. There's no way of connecting the two. Many of the people who actually analyzed the satellite data specifically said that and the ocean heat content, the actual workers in the field, the grunts actually collecting the data, admit up front that these two methodologies are totally incapable of measuring the power imbalance for the Earth with the required accuracy. And this fact is exacerbated by the fact that all of the various numbers are rapidly varying by large numbers. And the fudged the data are fudged to get around this. There are other important issues that I believe have been missed. The oceans are the big cloud factory. 70% of the Earth is ocean. And of the sunlight that falls on the ocean, 73% of it is used not for warming the Earth, not for warming the ocean, but simply for evaporating water and making clouds. This is the dominant process that is controlling. That's where the energy is going. Now, Ramanathan et al. In 1987, when he was analyzing the IRBI satellite data, divided the Earth up into two different areas. The clear sky area and the cloudy sky area. More recently, King et al. Have done some very beautiful work analyzing the Terra and Aqua satellite data. And they point out that there's a huge difference in the cloud covers over land and over ocean. So really, there are 4 important areas which have been totally ignored by all of the reports. There is the clear and cloudy sky over land and the clear and cloudy sky over the oceans. And since the oceans are 70% of the Earth, it's the ocean two that are clearly the dominant numbers. Now, the IPCC's reports totally ignore the fluctuations of the cloud cover, which are totally dominating, and they are what are in control. Okay, and finally, a very important error I have uncovered. If you look at the clear sky and the cloudy sky albedos, and you just simply apply conservation of energy, you find that the clear total albedo and the clear sky albedo, you can work backwards to get the cloudy sky albedo. That is clearly wrong by a factor of 2. Okay, so the first important task was to calculate and measure the Earth's power balance. Okay, what is it? That's the sunlight, the power in minus the power out. There are 2 components of the power. The power in is just the sunlight that's incident on the Earth. There are 2 components of the power that's out. It's the sunlight that gets reflected and the thermal heat that gets re-radiated. I call this sacred task because trillions of dollars are based on getting this number right, and they haven't done it. The power imbalance I will give you a house of cards argument that forebodes climate change and a climate apocalypse. And I will assert that there is no global, not proven global warming, and so the whole power house of cards collapses. Okay, the second is to measure the strength of the feedback stability. Okay, there are various mechanisms present. Obviously they are, because the Earth's temperature and climate have been incredibly stable over years. Now the IPCC scapegoats greenhouse gases are the dominant courses. Okay, the IPCC and especially Sherwood et al. Have claimed that these are insufficient and that we are very close to a tipping point. It gives you effectively a thermal runaway of the Earth. I think that's total nonsense, and I will show you in a minute how to calculate it correctly. Okay, so I will show you that the dominant process is the cloud thermostat mechanism, and assert again that there is no climate crisis. Okay, so what's this house of cards I'm talking about? They claim with great certainty, this is the IPCC and all of its contributors, that the Earth has a proven power imbalance, that there's more sunlight coming in than lost power going out. Okay, more power. Okay, it's basically Gauss's conservation law. If you have more energy coming in than is going out, you will have an energy buildup. So that has become the definition of global warming. Okay, that global warming in turn leads to a climate change. Climate change leads to an increased frequency of extreme weather events. Increased frequency of extreme weather events leads to a global apocalypse, a catastrophe, and a climate crisis. NOAA claims that they already observed this. I will show you that that is totally bogus. The IPCC claims that this power imbalance is due to a buildup of greenhouse gases. I further assert that the world must spend literally trillions of dollars to limit carbon production, greenhouse gas production, CO2 buildup. So I assert that the net warming power imbalance is not proven, it's not observed, correspondingly there's no climate crisis. The house of cards has collapsed, and the trillions of requested dollars are a total waste of money. Okay, first let's look at the computer modeling. It's done by the Goddard Institute of Space Studies in New York, which is where I actually wrote my PhD thesis. The studies that I will look at are the so-called CMIP-5. They were most commonly quoted. Now, I'm not the first to be critical of these. Steve Koonin just published a recent bestseller book, Unsettled, What Climate Science Tells Us and Why It Matters, and he was the first actually to call this to my attention, just how bad their predictions actually are. It's unable to simulate. Now, a second important picture that I will show you is the same set of computer modeling. It can't even get anywhere close to simulating the Earth's albedo. It's totally terrible. Okay, so this is this is on the back page of Physics Today. I mean, of the back page of American Physical Society News. It was published in the IPCC's AR5 report in 2013. Okay, these early curves here, the gray curves are history. They can't even simulate the history of the temperature. This is the temperature anomaly, whatever that means. They never tell you what that means. They just show you, okay, here's an anomaly, and so you can't apply sigma t to the fourth to it, so you actually cross-check how much power are we talking about. Okay, so not only can they not simulate the past, if you can't trust their simulation of the past, these are the variety of models that they have for it. None of them can actually, okay, the black curve is what they claim history actually has been. If they can't trust the history, then how can you trust the predictions? An important question is, what is the definition that we're using? Well, rather than the temperature, one needs to really get cause and effect in the right order. The power imbalance is what, in theory, is causing global warming. So one needs to look directly at the power imbalance rather than the temperature history. The temperature history, at least the measurements, there are huge variations from one spot over Earth, but most of them are over land, and 70% is ocean, where it's very hard to measure. So, and the land measurements all are suffering from the heat urban island effects. So the IPCC, in fact, even agrees with this and says, okay, we're going to define global warming as a net power imbalance, more power coming in than going out. Okay, next important question is, what is albedo? Well, it is a very confusing term to many. It's just a shorthand measure of the total reflectivity of light, of sunlight. It's the ratio of the outgoing solar radiation to the incoming solar radiation. Once it's outgoing, it's lost and it can't heat the Earth anymore. So measuring and calculating it essentially is equivalent to measuring calculating the Earth's albedo. Okay, this is a paper by Stevens et al. In 2015. Stevens has many of these papers, and with different et al. Associated with each one of them. Willie Soon earlier showed this. Okay, this is a direct copy from their Stevens et al. 2015 paper, showing the CMIP, all the colored curves are the CMIP-5 attempts. Now I have multiplied albedo times the solar constant, 340 watts per square meter, and so that gives me a total power. That means that the fluctuations here are the order of 10 watts per square meter. Remember, the imbalance that they claim is half a watt. or less. So they can't get anywhere closer than 10 watts, 20 times their claimed imbalance. Okay, the black curve is the measurements from the Terra and Aqua satellites. One should notice it is not sinusoidal. Okay. So here's this. So I've shown you the power. So that is consistent with what's been reported over and over again, the order of 100 watts per square meter of the Earth's surface area. Okay, now, that's multiplied by the solar constant. I'll point out the solar constant is not constant. Okay, so it's grossly incapable of simulating it. Okay, and so as an experimentalist, I would say this comparison with theory and experiment is a total flop. Okay, now if you get the outgoing solar power, reflected solar power, that reflects immediately into the power imbalance. So we got at least 10 to 15 watts, and the IPCC is claiming 0.7 or earlier 0.6 watts per square meter. This is an important number that will show up over and over again. I'll get to that in a minute. Okay, so here is, again from Stevens, here is the actual variation that he shows of the solar constant. This is due to the ellipticity of the Earth's orbit. Sometimes it's closer to the sun, sometimes it's farther away, and that gives you an added roughly 22 watts per square meter power variation. Okay. Okay, so I assume that we're going to show that the warming is defined as more power in than power out. Okay, and so here, I think I mentioned that out has two components. One is the sunlight energy that's directly reflected back out into Earth. That's about 100 watts per square meter. The other component is the far infrared. It's about 240 watts. Okay, the climate scientists refer to this as short wave and long wave radiation. It means far infrared and the full spectrum of sunlight. Okay, so should be easy. If you want to measure power imbalance, there are three numbers you got to measure. There's the total power in. That's just looking up at the sun, the sunlight, and looking down at the Earth, how much reflected sunlight is there, and how much heat is being re-radiated by the Earth. It's actually a much harder problem than it sounds. It's not just measuring these numbers and subtracting, because these numbers are wildly fluctuating in time. They're irreproducibly fluctuating. The cloud cover varies quite dramatically. The total amount of sunlight reflected by the clouds is varying quite dramatically. And these numbers are so big that the difference is very, very small. So it's very, very hard to actually make such a measurement. Okay, and moreover, the observers themselves say, this is such a tough problem, we don't think we can actually do it. We don't have the technology available to actually measure to the required accuracy. So what has been employed? There are two important sets of satellites. The earliest one is the Irby satellite that went up. And then there was a very nice pair of satellites, Terra and Aqua satellites, that were in solar synchronous orbits. And they went around exactly the same orbit once a day, every day. And there's also the ocean heat content data, and that was measured by the Argo buoy chain and also XBT water sampling by ships. And then there was also another ground, the BSR and the baseline surface radiation network that looked simply had pyroheliometers looking up at the sky. Okay, these all different agreements, and it was shown earlier that the Irby satellite difference was huge on the compared to the Terra and Aqua satellites. Okay, there are, in most of these cases, there are huge gaps in the data. Something goes wrong and they don't collect the data, and or they just don't have enough money to analyze all the data. And we will show you that none of the reported data actually show a convincing warming power imbalance. And worse yet, of the data that have been analyzed, they just simply fudge the numbers. And they will change what, if you just simply subtract their numbers, subtraction shows there's no warming. They just simply write on there on the output that there is warming. Okay, so where do you get the numbers? Well, most of these are all on what I call a power flow map. Saw one earlier. I'll show you a whole bunch of them, and they're generally reported at the top of the atmosphere altitude. So all you have to do is look at the power flow map, pull the numbers, and do the subtraction. And if you don't believe me, don't believe they're fudging, I urge you, pull these graphs out and do the subtraction yourself. Okay, so here's the typical calculation. We have roughly 340 watts of incident shortwave power or sunlight power coming in, 100 watts reflected, 240 watts of outgoing long-wave power, and plus, minus, minus, we get an imbalance. Okay, now there are a couple of important tricks in doing this you need to notice. They also, if you have error bars associated with each of these numbers, the standard method, I personally recommend Bevington analysis of experimental data for scientists and engineers, a marvelous book. But the standard method is it's the root mean square sum of the individual errors. And what does this tell you? There's an immediate cross-check that should catch your attention. Everyone, that the total imbalance should always be bigger than every single one of the individual errors. And then if you have the imbalance is less than the error bar, then you can then there's no global warming. If it's greater, then you can claim global warming. And I will show you that there is a very what I refer to as the bad penny. The bad penny proverbially always shows up again. Okay, so the earliest data, Stevens et al., 1981, and then what was followed by Ramanathan in 1987. Okay, those are the numbers that they use. They reported, Stevens et al. Said there was plus 9 watts of warming, plus or minus 10. I add the numbers, I get to 6.8. Ramanathan doesn't put on the final digit, and he gets 0. There, his numbers end up to minus 3. And analyzing the same data, they only took data for portions of 4 months. And remember that the output power was not sinusoidal. The National Academy report reviewed that, and their comment was, the observations do not meet quality standards. Okay, this was shown before. Loeb et al. In 2012. He admits, this is a direct quote from the paper, limitation of the satellite data is their inability to provide absolute measure of the net top of the atmosphere radiation imbalance to the required accuracy level. So he correspondingly says, okay, so satellites don't work, or at least the Irby satellite doesn't work. So he just goes in and arbitrarily replaces Ramanathan's numbers. Now, both of these have huge data gaps, terribly undersampled data. And so Loeb et al. Just simply showed the numbers and said, okay, we do have a net warming. Okay, and the way they did this was they followed Hansen's recommendations, 2005 and 2011, who said, well, you really got to look at the ocean heat content. That's where the accurate numbers could come from. Now, this is before El Nino current flows and this very complicated structure of the ocean, and we had just a very sparse buoy chain trying to measure the ocean heat content just by measuring temperatures. And some of it was just done by ship-based guys throwing buckets overboard and measuring the temperature with a thermometer. Okay, so they Loeb et al. Adjusted the numbers, and so what they got from the Irby Earth radiation experiment, UREB, I forget what it is, satellite, the ocean heat content, and finally they come up from the ocean heat content with this important number, 0.64 plus or minus 0.11. This is the bad penny that keeps coming back. Okay, so by changing the numbers, they're admitted that yes, we're fudging the results. Okay, Stevens et al. Looked at this, and Stevens et al. Joined forces with Loeb's group, and they used, again, ocean heat content data and the adjustment, fudge, I would call it, and these are the numbers that they got. Okay, I add these numbers, and here's what I get, 0.5 plus or minus 3.9. Okay, Amazo, we get this 0.6. Now, at least what they did was they raised the error bar limit from 0.11 to 0.4. Okay, so they admit that they fudged the numbers. But they don't admit that they can't do arithmetic. They do not show where they got their error bars from. And if you look at it, it immediately fails this error bar cross-check that I mentioned. Okay, so here is their power balance flow diagram. So here's sunlight coming in. Here's reflected sunlight going out. Here's the re-emitted infrared. And they're trying to compare it with the CMIP5 calculations. Their numbers on the graph just don't even add. Okay. Lecoyer was one of the co-authors. He apparently, I guess, this may be perhaps a minority report. He went back and reanalyzed the ocean heat content data. And now he did shift the numbers. He didn't call them adjustments. He called them minimizing constraints. He still got the similar numbers, but we got all of his numbers show 0 warming. from ocean heat content. Here is his Lecoyer et al. Here's the outgoing solar, outgoing heat. Here's incoming solar, 340 plus or minus 0.5. Outgoing solar, 102 plus or minus 4. But while we're here, keep this number will keep recurring. This is the power for evaporating of water. I'll get back to that in a minute. Okay, so in 2010, Trenberth et al. Looked at this. Trenberth and Fasulo were kind of the original whistleblowers on all of this, and they were pointing out that you're doing an apples and oranges comparison if you're trying to look at the ocean heat content, because that's occurring at the surface of the Earth. And whereas if we were in theory doing a top of the atmosphere calculation. So so if you want to try to mix up surface and top of the atmosphere, you need to know what's going on in between. Trenberth and Fasulo did not agree. And so they're it was Hansen who was really pushing the ocean heat content data. But what Trenberth and Fasulo point out is that there's a huge missing energy balance. And they keep asking the simple question, where did the energy go? Left it unanswered. Okay. There was a response from Hansen et al. In 2011, and he says, oh, it's just satellite calibration errors. Okay, so then we had so Lecoyer was one of the co-authors with Stevens, and so we had a major discrepancy between the two. So they get together, just the two authors, in 2015, Stevens and Lecoyer, and they come up with this absolutely amazing paper. It reminds me of the line from Monty Python and the Holy Grail. Yeah, we did put the carrot on her nose, but she's still a witch. Okay, so in the paper, they say that they're both right. That yes, they're both in agreement, and that guess what? It's 0.6 plus or minus 0.4, the bad penny. Okay. And they admit that the choice between OHC and satellite data was made in a totally ad hoc fashion, and that they had absolutely no reason to support one approach over the other. Those are just direct quotes from their paper. So here is their power flow diagram, same set of numbers. Now that the top line has two numbers, one from satellites and one from OHC data. Okay, so here's what they come up with. Here's the OHC data. Here's the Terra and Aqua satellite data. And for both of them, add up to 0.6 plus or minus 0.4. Okay, I add up the numbers, and I get 0 plus or minus 5.6, showing no convincing warming. Where they say, oh yes, we have lots of warming, and our errors are very, again, here, this flunking the RMS error test. Okay, then time progresses a little bit, and Wild et al. In 2019, and followed by IPCC itself, cementing as total approval in their AR6 2021 report. All of these numbers are fudged. Okay, so Wild et al., they report a new clear sky or cloud-free sky measurement from the baseline surface radiation network. And this allows them to calculate a clear sky albedo. Okay, and so then AR6 just simply took their picture and made a near perfect copy, except they changed the numbers and they made the fudges worse. These are just copied directly out of their papers. Okay, this one is Wild et al. This one is AR6. Again, here we have 340, 100, 239 going out. Now remember these numbers here. These are important. This is the total heat from evaporation, 82 watts and 160 watts absorbed. They'll be important in a minute. Okay, so here's their arithmetic. Okay, so here's Wild et al.'s numbers. I calculated 3.5 plus or minus 3.6, no warming. Guess what they get? 0.6 plus or minus 0.4. Okay, oh well, AR6 adjust that a little bit, 0.7. But they dropped the error bars now by down to half of that. And it's actually, they dropped it by a factor of 4 because they are claiming 2 sigma error bars. Okay, so again, our bad penny keeps showing up, and again, the RMS error sum check doesn't work. The arithmetic is fudged, and okay, now they have a new trick for fudging that I hadn't seen before. This is really cute, where you'll notice that they report not error bars, but they give you 2 numbers with no decimal point behind them. So the round up error is 0.5 watts, which is the same order of magnitude as the net difference that they're calculating. And okay, so here is this is Stevenson. I think he's out of order. This is Stevenson, Lecuye's. Okay, Alice, I already gave you that one. Oh, I'm going backwards. That's the problem. Okay, now there are 2 important observations that just get in passing. The cloudy sky albedo, we can calculate from that because we have now the total whole sky and the clear sky albedo. It gives you an error by a factor of 2, and the 73% of the sunlight is used for warming. Okay, how do we do this? There's a simple energy conservation theorem. Actually, SES noticed this back in 1976, that it says that the all sky, when you have a multiplicity of regions, in this case 2, clear sky and cloudy sky, that the total albedo is just the area fraction weighted sum of the 2 albedos. Okay, so we can know just from looking at that, the total sky albedo, the whole sky albedo is 0.3. The clear sky albedo is 0.33. So correspondingly, if you and everybody agrees that the total average cloud fraction of the Earth is about 0.67, and so this gives you this number 0.36. That's the reflectivity of bright white clouds. That's clearly wrong by at least a factor of 2. Okay, so the other question is, what does the sunlight actually do? Most people say, well, it warms the Earth, right? Well, that may be true over land, but land is only 30% of the Earth. Most of the area, 70%, is ocean. So virtually all of the exposed water on the Earth is in the ocean. There are a few big lakes, Great Lakes, Lake Baikal, whatever, but effectively everything is ocean. Okay, remember we had 160 watts was absorbed. So 70% of that is absorbed, so it's 112 watts. We had 82 watts used for evaporating water. That ratio is 73%. That comes straight off of AR6. Okay, the final total fudge was made by NOAA, and this was a Physics Today article by they claim that there's an observed increase in the frequency of extreme weather events. It was by Lubchenco, who is not a scientist, is an undersecretary of commerce, and Thomas Carl, who was NOAA director of their whole climate science program. So presumably the director of the NOAA's climate science program can get the very best data that NOAA has to offer. Okay, they assert they construct a weather climate extremes index. It's some sort of they don't give you exactly how they calculate it, but it's some sort of a numerical composite measure of extreme weather events. These include hot spells, cold spells, droughts, floods, landfalling hurricanes. Conspicuously absent from the list is EF3 plus tornadoes. And as Steve Koonin points out in his book, well, that's because they can't put them in there because that was actually decreasing, and it would show the opposite of what they wanted to show. And they assert that the frequency has obviously increased over the last 3 decades. Okay, there is their graph. I learned from 2 great experimentalists, Charlie Towns and Louis Alvarez at Cal. Louis Alvarez would look at that and say, flattest line I ever saw. And Charlie Towns would look at that and say, I don't see in the data what you're telling me I'm supposed to see. Okay, so I took those data. No scientist uses bar graphs. Okay, they all use point graphs. And so I just traced that data set directly. And I did it twice, once under transparency, and I flipped one of them. So that now time is increasing to the left. If you look carefully, you'll see they're mirror images of each other. I won't tell you which is which. But you have to look at this and tell me, yes, it is obvious in the last 3 decades that there's a huge increase in the extreme weather event frequency. If you can't tell them apart, I assert that's a totally phony claim. Okay, so what are the conclusions from all this? Okay, they claim a net warming energy imbalance. I claim that I assert that those claims are totally false. The net warming imbalance is the definition, and so there is no energy crisis, energy imbalance crisis without global warming. There's no climate crisis will not occur. Okay, so the IPCC has based its warming claims on computer modeling and on various observational modalities. The computer models are grossly flawed. They also based on fudged data. Okay, so the modeling predictions are totally unreliable. And if you can't even explain the past, how are you going to reliably predict the future? None of the observational modalities convincingly shows that there is a global warming. Okay, the IPCC, those kept going over and over and over again, this bad penny showing up. This can't be done accidentally. This has got to be dishonest. I'm embarrassed to say this, but, and if you don't believe me, just check my arithmetic. Okay, moreover, I assert that there's a very serious factor of 2 missing in the calculation of the cloudy sky albedo. I suspect this is much worse. I haven't tracked it down where it is. I don't have access to the data. So, and I mentioned that the NOAA has claimed that it's already caused extreme weather events. That's clearly wrong. So I consider this good news or great news. What you have heard from the IPCC is wrong. There is no climate crisis. The Earth is not in peril. I think that's a good thing. Okay. Thank you. And the bad news is this is a total hoax. So, question is, what is really happening here? Why is the Earth's climate as stable as it really is? Okay, I will just now describe what I call my cloud thermostat mechanism and show that it's the dominant process controlling the Earth. It offers a very, very powerful feedback mechanism, and I'll show you how to calculate it. The great strength is occurring from these huge fluctuations that are observed in the power imbalance. Okay, how does it work? Well, clouds are effectively modulating the outgoing shortwave power, the outgoing reflected sunlight, and they control the Earth's, and there's at least 18 watts available, and it's actually much bigger than that, and much, much bigger than the claimed power imbalance. Okay, but remember that I mentioned that we seem to have a problem in calculating what is the actual total albedo of the Earth and what is the cloudy sky albedo. So Wild et al. Think it is 0.36, although they never calculated it, but you just get that if you apply conservation of energy. So I will actually do the calculation both ways, where I'll say, all right, say they're right, say it's 0.36, or I'll also calculate it using a much more realistic number of about 0.8. Okay. So the fluctuation of the clouds is measured by a very beautiful set of experiments by King et al. And now finally Stevens et al. Mentioned in 2015. Stevens last also shows you this non-periodic oscillation of the Earth's albedo. Okay, so this thermostat works just like the thermostat in your home. The power imbalance is never zero. Your furnace is always fully on or fully off. All that happens in what the thermostat does is it modulates, for various heat leaks coming in, changing, modulates the duty cycle of the power on. Okay, mention some rather underappreciated conspicuous properties of cloud. Okay, I already mentioned that involves the dominant use of sunlight energy over the oceans is 73%. And we'll show you in a minute that it is by far the strongest feedback mechanism allowed. Okay, okay, so it increases well, I'll show you the numbers in a minute. Okay, so let's look at a few pictures. Here's a few. You can go to NASA's website and get lots and lots of satellite pictures. One on the left was the astronauts' original Earthrise picture taken when they were first emerging from behind the moon. Okay, so here has a very low cloud cover. Various areas also have a very small cloud cover. Here's the Pacific Ocean, lots and lots of clouds. Here's over Australia. Here's over, I've got a whole bunch of pictures of Africa showing huge variations just in the cloud cover. You notice that these clouds are bright white, okay, and that the cloud cover varies very strongly over the Earth. Okay, clouds are clearly reflecting a lot more sunlight than the rest of the planet. Okay, the photos look like about 0.8 or 80%, 90% of the light. For comparison purposes, a sheet of white paper has a reflectivity of 0.99, and those are a lot closer to a sheet of white paper than the oceans are. Okay, the oceans are about, and land are about 0.16. They're browns and greens or dark blue. Okay, so what they're saying is, what Wild et al. Are saying is that the reflectivity of clouds is about equal to the average reflectivity of the whole Earth. That's clearly wrong just by looking at the pictures. Okay, what do we also know about clouds? They cast dark shadows. If you're in an airplane in a partly cloudy sky and you look down at the ground, you can see the dark shadows below the clouds. Now, a lot of the illumination in the clouds is actually by the blue sky really scattering in between, so they're actually much darker than they look. Okay, or just driving along a mountain road and look down in the valley and you can see the cloud shadows. They're really dark. Alternatively, if you have an ammeter on your solar panels, which I did when I was sailing to Hawaii, I was sitting there watching that and found just even a simple solitary cloud passes over your solar panels, the output of the solar panel drops to 1/2 or less. Okay, worse yet. Say you're indoors on an overcast day, okay, and you're trying to read a book. You can't do it because it's just too dark. Where'd all that sunlight go that allowed you to read the book on a sunny day? It gets reflected back out into space. So, again, I mentioned, what did we notice from the just looking at the AR6 power flow diagram? 70% falls on the oceans. The oceans are the big cloud factory. That's where all the water is, and 73% is used for making clouds and not for. Okay, now here's a very appreciated article by King et al. In 2013, and he separated out the Terra and Aqua satellite data into separate groups for over ocean and over land. Very different cloud, and what he measures is the cloud fraction area, coverage area fraction. And the blue curve in the middle is the average of the two. Okay, so I have added on power scales just like I did earlier. Okay, so multiplied by, say, our assumed solar constant, 340 watts times the, well, I need to assume reflectivity of the clouds. So I used two choices. Assuming the cloud reflectivity is 0.36 and 0.8. I will point out that the IPCC reports totally ignore, don't even acknowledge the existence of this paper. Okay, so we have okay, so we have the left-hand curve. I'm assuming an all-sky albedo of 0.3, clear sky albedo of 0.16. That's what the IPCC uses. And so that gives you a 0.36 for the albedo of the clouds. So you can see here that okay, so clouds that pass from ocean to land go from here to here. And those are the clouds that control most of the weather. At least they do in the North American continent. I'm assuming that's true elsewhere. I happen to live there, so I'm quite familiar with that. When they pass from the ocean to the land, that's the difference, and that's the change in the power. Okay, so here I'm using a more realistic measure of the cloud albedo of 0.8, and that gives that the fluctuation is the order of 55 watts per square meter. Remember, they claim that the IPCC in the bad penny is 0.6 watts per square meter. And if you add in the additional variation in the solar constant of about 22 watts, we're looking at 77 watts per square meter fluctuation in the power imbalance. Moreover, this is not slow. These two satellites pass over the equator an hour and a half apart. 3.5 hours apart. The dotted line here is from the Aqua satellite that passes over at the equator at 1:30. Solid line is from the Terra, which passes over the equator at 10:30 in the morning. And so this is just in a matter of 3 hours the change in cloud cover. This is presumably due to the fact that if you actually look at the cloud cover during the evening, it continuously builds on the oceans until about 3 or 4 5 in the morning, and then as one of my friends, one of the world's greatest ocean race navigators, beware the last squall of the morning, because that dumps a lot of water and there's a lot of wind in it. Okay. So remember those huge albedo fluctuations that Stevens et al. In 2015 noticed? They are clearly due to changes in the cloud variation. He never seems to realize that. Okay, so how does it work? Remember, we got most of the power is being used for making clouds and for evaporating seawater. And the Earth has a very strongly varying cloud cover. The temperature control works exactly the same way as your home thermostat does. It corrects for temperature in the presence of varying modest heat leaks. For the presence of CO2 in the Earth's atmosphere, doesn't matter where it came from. It's actually a very small heat leak. We saw on some earlier satellites. It's only the order of 2 watts. Is what's supposed to do to CO2. So there's never zero power imbalance. Okay, so how does it work? Okay, so when you have a high cloud cover, there are a lot of shadows on the ocean. The shadows, clouds are present that essentially, the shadows are essentially turning off the sunlight that's hitting the ocean. So the furnace is on. Clouds are not present. The furnace is fully on. So cloudy days are everywhere are generally cooler than sunny days. So when the cloud cover is too high, the furnace is off. The sea surface temperature is low. And remember, we need sunlight to evaporate water. It's a very sensitive function of the air temperature. The evaporation rate is a very sensitive function of the air temperature over the water. So if we just cool it down just a little bit, we pretty well kill the evaporation rate. So we've killed the evaporation rate. So we had too many clouds. So quickly the cloud production rate drops, the cloud cover fraction drops, temperature increases, equilibrium is restored. The opposite happens when the cloud cover is too low. So depending upon your assumption, we have at least anywhere from 18 to 55 watts available just to include a very wimpy heat leak. And no matter what, this is all trivial compared to the 2 watts maximum from CO2. Okay, let's look at the feedback strength. Okay, this was the IPCC's second important sacred measurement. Okay, so question is, why is the Earth just as temperature and climate as stable as it really is? So there are a variety of feedback mechanisms proposed, and there are a variety of analyses of these. One of the earlier ones is the National Academy, National Research Council report, Understanding Climate Change Feedbacks. There's a second one by Sherwood et al. Steve Koonin was the one who called this a very important paper to my attention. This is the so-called Ringsburg-Castle study. And then also by AR6 itself, pretty much all of chapter 7.4. So I have followed the methodology that Sherwood et al. Used, and I outlined that in Appendix C, available for questions period. They had a very restrictive assumption in there that they would not allow cloud fraction to be used as an intermediate variable. That's, in my opinion, that was totally silly, and why they never even noticed this. Sess et al., curiously, in '76 did use it, but that got forgotten. Okay, so you could evaluate again. I remember that I had 2 different possible cloud albedos, 0.36 and 0.8. So we have minus 5.7 is what I calculate. And for a more reasonable choice, minus 12.7. Values I've taken the graph from IPCC's AR6, figure 7.1, and plotted those numbers on it. And in either scenario, is by far the most powerful feedback mechanism. Here is from AR6. This is the cloud feedback strengths. Okay, this is a water vapor feedback, surface albedo. Here's what they claim for cloud feedbacks. They claim it's a positive destabilizing error. And so here is what they call Planck feedback. I assert that it's misnamed. It's really Stefan Boltzmann. Planck came along 21 years later, but somehow rebranding is in. Maybe he was racist. I know. Who knows why they renamed it? Anyway, so here's what they claim. This was the it's the sigma t to the fourth, the fact that we have a fourth power for the power output just from the thermal heat is what does the stabilizing. Okay, so you take, and so I move that, and here's what I calculate here for clouds, negative feedback. This is for the 0.36. This is the IPCC's albedo. Here's what I calculate if I use a very reasonable sounding albedo. So, and if you take the sum of them all, it's clear down to here. So we're clearly moving a lot more powerful feedback. So what are my conclusions? Okay, so clearly this is the most powerful feedback mechanism. It's what is keeping the Earth's climate stable. Okay, it's used from -1 to -12 or -13. Okay, the size of this just, I think, confirms this is the dominant mechanism. And it gets its strength from the fact that we have these huge fluctuations. This is the power of how strong is your furnace. It's anywhere up to like 77 watts per square meter. Okay, so this is what people are spending trillions of dollars to do. They call it a solar radiation management system. I claim it already exists. It's built in. Nature has built it into it's our own cloud factory. It works very well. It stabilizes the Earth's temperature, and it's free. All of the IPCC's mechanisms cost trillions of dollars per year. So, what are my recommendations? Hey, if AR6 can give recommendations to policymakers, I will take that opportunity here. There is no climate crisis. There clearly is an energy crisis. We are a very serious energy crisis, and if we have to handicap ourselves by worrying about how we get our energy, this is very dangerous. Government is needlessly spending trillions of dollars to limit CO2 and methane. They are not pollutants. This very fact, the claiming they are pollutants, this went on under Lisa Jackson, who was President Obama's EPA director, claiming that getting them on, this was a power grab, because that put her in control of using the Clean Air Act and took it away from Steve Chu. Okay, so they're mandating trillions of dollars spent on this zero carbon policy. That, my recommendation, that is totally crazy, and you should eliminate it. Trillions of dollars can be saved by limiting carbon caps, carbon credits, carbon sequestration, carbon footprints, zero carbon targets, carbon taxes, anti-carbon policies, fossil fuel limits in energy policy, okay? Subsidies on spin-off industries like electric vehicles, all-electric power, solar, wind should be eliminated. If they can't stand on their own economically, okay, I am not in the pocket of the oil industry or the coal industry, but fossil fuels are perfectly okay to use. Okay, so the IPCC has all these geoengineering projects. They're totally crazy. They're trying to do carbon capture, limit the CO2 levels. They're totally crazy and should be totally eliminated if they're there for doing global warming. Okay, so I end with Everett Dirksen's famous line in the this 1969 regarding the simultaneous funding of the Vietnam War and Apollo programs. I will update it for inflation. $1 trillion here, $1 trillion there, and pretty soon you're talking about real money. Okay. Okay, for appendices, if you need them, if you get copies of the slides, here is this albedo theorem that shows that the total albedo is just the weighted sum of the individual area albedos. Okay, and there's a corollary. If you know the all sky albedos, the cloud fraction, and the clear sky albedos, you can calculate the cloudy sky albedo, which is what I did to get the 0.36. Okay, here is how you calculate the feedback. This is how you apply it to the data from the AR6 power balance. Okay, here is the feedback analysis that I can just pull this straight out of Sherwood et al., the Ringsford-Castle study, and plug in. They assumed that they use the chain rule for calculating the effectively the various components of processes. They prohibit the use of, for some reason, they just simply prohibit the use of cloud cover area fraction as an intermediate variable in the chain calculus chain rule. Okay, so here's where if you plug in the numbers, it's just simply doing exactly what they do. Is it modulates the shortwave downward power. Oops. Okay, so here's you calculate the final numbers to get the feedback strength. Okay, I'm open for questions now, assuming we have time. Thank you.